Hello, everybody, and welcome back to Calculus 3 online at FCC. This lecture is the second portion of the lecture for partial derivatives of functions of two variables. And we're not going to learn anything completely brand new that we haven't already learned in the previous lecture, but we're just going to discuss few more examples and practice on computing partial derivatives. So here you see a function of two variables, sine 3x minus 2y plus cosine of x plus 4y. And we would like to compute all four second partial derivatives. And we're going to see if we can come up with some conclusion once that's done. All right, so let's start with the first partial with respect to x. Okay. So following the same steps as before, we hold in y as a constant and x is the variable. So this gives us what? Derivative of sine is cosine of 3x minus 2y times the derivative of the inside with respect to x, and that's 3. So I'm going to put it up front here. Okay. Then the derivative of cosine is negative sine. So negative sine of x plus 4y. Okay. The derivative of the argument with respect to x is 1. Okay. So this is my first derivative with respect to x. Let's go ahead and compute the second derivative with respect to x. So second, okay, the notation would be f sub xx. So I'm going to take the first derivative with respect to x and differentiate it again with respect to x. Okay. Let's see, one at a time. The derivative of cosine is negative sine. So I'm going to put it right up here. Negative sine. The argument is the same. Okay. 3 is still there. I'm just going to remember it. But now times the derivative of the inside with respect to x. So let me write it out here. So we remember 3x minus 2y d dx of this is 3. Okay. So 3 times 3, that gives us 9. So that's the first part. Okay. What about the second part? The derivative of sine is positive cosine. Okay, so still we have a cosine here, x plus 4y. That's the argument, and the derivative of that argument with respect to x is 1. Okay, so that's what we have for the second partial derivative with respect to x. Okay, you can see there's nothing here that can be combined or simplified, so we'll leave it as is. So one derivative is found. Okay, it says all four second partial derivatives. Okay, so we got that. Let's go ahead and do the same thing with respect to y. So f sub y. Okay, derivative of sine is cosine. The argument stays the same. And now the derivative of this argument with respect to y is going to be negative 2, right? So negative 2 comes here. Okay. Second portion, let's see, derivative of cosine is negative sine. Oh, let me fix that. So this would be x plus 4y. Okay. The derivative of this argument with respect to y, so that's x plus 4y, is 4. Okay, so my first derivative, first partial with respect to y is negative 2 cosine 3x minus 2y minus 4 sine of x plus 4y. Okay, now let's go ahead and compute the second derivative with respect to y. So that's the first derivative differentiate it again. Okay, so similar steps here. The derivative of cosine is negative sine. Okay, so negative sine, and then also there's another negative from the argument, so there are 3 negatives total. So we're going to keep that negative here. So negative sine of 3x minus 2y. Okay, and then the derivative of the inside with respect to y, we know that that's negative 2. Oh, did I never write it? Okay, there we go. This is negative 2. Okay, so that will give us 4. Okay, you can kind of keep track of all the negatives, and you'll see that that's going to be, the final result will be negative, right? And then minus, let's see what we get here. The derivative of sine is positive cosine. Okay, so cosine over here, x plus 4y. And then what happens here? The derivative of the inside with respect to y is 4. So 4 times 4, and this is 16. Okay, so this is the second partial derivative, okay, that we needed to find, f sub yy, and it is negative 4 sine of 3x minus 2y minus 16 cosine of x plus 4y. Okay, so we have to find 2 more. What are those? Those are mixed second partial derivatives. Okay, let me go ahead and switch color to differentiate it a little bit. So let's do f x y. Okay, so what is that? It's the first derivative with respect to x differentiated with respect to y. Okay, so this would be d dy of which expression? That would be 3 cosine 3x minus 2y minus sine of x plus 4y. Okay, we're going to compute the partial with respect to y of this function, which comes from here, right? Okay, let's go ahead and do that. So what do we get? All right, derivative of cosine is negative sine. So I'm going to put a negative here. And remember there is a 3 there. So sine 3x minus 2y. Now we're differentiating with respect to y. The derivative of that is negative 2. So negative 2, and then there's also negative up front, times negative 3, that gives us positive 6. Okay, let me highlight it, where that negative 2 comes from, right here, right? Okay, the derivative of the inside with respect to y. Okay, 6 sine of 3x minus 2y, that's our first term. Okay, derivative of sine is cosine, so that goes here, of x plus 4y, and the derivative of this argument with respect to y is 4. So this is what we get for f sub xy. Okay. All right, let's go ahead and compute our last second partial derivative. So that would be f sub, we've already done that one. So this would be yx. Okay. Let's see. So what would that mean? So this would be f with respect to y first, then with respect to x. Okay, so d dx of which function? Now we're going to take negative 2 cosine of 3x minus 2y minus 4 sine of x plus 4y. So we're differentiating this expression with respect to x. What does that come from? That's this one right here. All right, let's see what we get. Okay, the derivative of cosine is negative sine. Okay, so here's my negative 2 times negative sine of 3x minus 2y. And then what else? Times the derivative of the inside with respect to x. And that's 3. So let's write it out here for now. Okay, and then the derivative of sine is cosine, right? So this would be negative 4 cosine of x plus 4y times what? Times the derivative of the inside with respect to x, and that's 1. Okay, so if we clean this up a little bit, let's see, what do we get? We get positive, so here's negative 2 times negative times 3, so that's positive 6 sine of 2x minus 3. Oops, sorry, let me go ahead and fix that. So that would be 3x minus 2y. And then minus 4 sine of x plus 4y. And you probably already noticed that they are the same. So this expression right here and this are identical. Okay, this is not a coincidence. We can say that f with respect to x then y is the same as, excuse me, f with respect to y then x. Okay, that we can say, and we will use that back a little bit later on in the course, okay, to test some object for some property. I know I'm a little bit cryptic right now, but we will be using this particular property of functions when we start talking about vector fields. All right, so this is a nice problem to both test your understanding of how to compute derivatives, partial derivatives, second partial derivatives, and also kind of leads you to this conclusion that, yeah, all right, if you compute the second partial derivative, the mixed ones turned out to be the same. Okay, all right, let's go ahead and take a look at the last problem for this lecture, where we're asked to just evaluate our partials at a specific point. Okay, so our function in this case is tangent inverse of y over x. So if you like to write it like this, let me go ahead and rewrite this function a little bit. This would be tangent inverse of y over x. Okay, then it says compute the following: df dx evaluated at the point 2, -2, and also df dy evaluated at the point 2, -2. Same point, right? Okay. All right, let's go ahead and do that. So df dx, this is the partial of tangent inverse y over x with respect to x. Okay, so tangent inverse prime, what is this? That would be 1 over 1 plus whatever my argument is squared, and then by chain rule times d dx of y over x. Okay. All right, so what do we get here? So this will be 1 over, let me write it like this, 1 plus y squared over x squared, so that's my denominator. And then the derivative of this expression, what is this? Remember, y is a constant, x is the variable here, and it's to the negative first power. So if I were to differentiate this, this would be negative y over x squared, right? Okay, so this is times negative y over x squared. Okay, and now I'm going to multiply this x squared through this expression here. Okay, gives me a nice expression, negative y over x squared plus y squared. So this is going to be the partial derivative with respect to x. And now we can evaluate this. So let's go ahead and evaluate it. df dx evaluated at the point 2, -2. Okay, what do we get? This is going to be negative 2 on top, and then here we get 2 squared plus -2 squared. So this becomes positive 2 over 8, right? Which is positive 1/4. Okay. So that's this evaluation process. Similarly, we can do for the partial with respect to y. So this would be df dy. Okay. Same idea. The derivative of tangent inverse would be 1 over 1 plus y over x squared times partial with respect to y. So in this case, you can think about it as 1 over x times y, right? 1 over x is the constant and y is the variable. So if I take the derivative of this, what does that give me? That's just 1 over x. Okay? All right, so this becomes 1 over 1 plus y squared over x squared times 1 over x. And to simplify this, I'm going to use this trick when I'm going to multiply top and bottom by x. We can do that because we know that x is not equal to 0 for sure. Otherwise, this whole thing is undefined. Okay, so now we have this expression that's easy to simplify. This simplifies to be x on top. Now, look, this becomes x squared, right? And if once again, if I distribute this, this gives me a nice expression. So on the bottom, we're going to get x squared plus y squared. Okay, that's my partial with respect to y. And I'm going to evaluate this. So df dy evaluated at the point 2, -2. It's going to be the same answer, right? So 2 over 2 squared plus -2 squared. So that's 2 over 8. And the answer is also 1/4. Okay. All right. So what does that number give us? Gives us the instantaneous rate of change of the function at the point 2, -2. For the first one, if we're going in the x direction with y being fixed. For the second one, if we're going in the y direction with x being fixed. Okay. So let's see. Let's go ahead and review real quick what we've done. In the first example, we've computed second partial derivatives, and we came to a conclusion that the mixed ones should be the same. Okay, and here we practiced it a little bit more with finding derivatives, partial derivatives, and also evaluating it. So in the next lecture, we're going to talk about approximation of surfaces with tangent planes. So this is kind of like an extension of the problem that we've done in Calculus 1, where we computed the derivative and said, well, now how about we find an equation of a tangent line, right? Except now we're going to be computing equations of tangent planes. So that's what we'll do next time. Thank you all for watching, and I'll talk to you next time.